So an adjacency matrix is a two-dimensional array that shows whether there is a relationship between two objects. So you can use an adjacency matrix to be the data structure that you may then create a graph from. So below you can see how this can be used to represent an undirected graph. So we've got our undirected graph here. We've got an adjacency matrix here. So because it's undirected, we can simply put, so for this relationship here, A to B, we need a 1 in both A to B and B to A because it's got no direction. All right, so an undirected graph, we can use that adjacency matrix, and if you follow it through, press pause and have a look through in more detail, you can see that each of the edges is represented. We could also use an adjacency matrix to represent the directed graph. Now, it doesn't matter whether you read it column to row or row to column, as long as you're consistent and you program the computer how to read it. But adjacency matrix, again, two-dimensional array, we can do it to hold direction. So we can say A to B, we can go A to B, look, but B to A is a 0. So now that relationship between those two objects has a direction. Okay, so you can see how this can be used again to represent a directed graph. Finally, you could have a weighted graph. So whether it's directed or undirected follows the principles of the previous two slides. But again, we can use our adjacency matrix to store, instead of storing simple like zeros and ones, y or n, whatever, we can store our actual weights. So again, whatever the weights mean, we can store our actual numbers in there to represent weights. But obviously, for our weights and numbers, we can't have a 0, meaning there's no relationship. We would have to substitute like a hyphen or something like that to mean no relationship.